Shri Gurubhyo Namaha. Very good morning, my dear children. In the previous session, we had a brief lecture on galvanic cell, differences between electrolytic cell and galvanic cell, role of salt bridge in galvanic cell, electrode potential and standard electropotential. Quickly, let me revise a few points. The standard potential of any galvanic cell is a sum of the standard half cell potential for the oxidation and reduction half cell. I hope you have revised the formula. E naught cell is equal to E naught oxidation plus E naught reduction. So, standard half cell potential are always mentioned as a reduction process. Once again, let me repeat it. So, standard half cell potential are always mentioned as a reduction process. The sign must be changed for the oxidation process, so that we have included minus E of reduction. I hope you remember that. Now, I am sure you must have revised the above mentioned topics, so that it will be very easy to understand today's session. So, in today's session, let us learn standard hydrogen electrode and how to calculate potential of any cell. Children, I am very sure you must be noting down all the keywords mentioned in the slide. In the last session, we have studied E cell is equal to E reduction potential of cathode minus ERP, that is reduction potential of anode. Now, if this is calculated under standard condition, it can be mentioned as E naught cell is equal to E naught reduction potential of cathode, E naught reduction potential of anode. This is there in the NCERT. Please remember that, note it down. Now, how to calculate EMF of half cell? So, let us learn the method. There are two types of calculation. The first one is standard potential, the second one is non-standard potential. So, let me discuss the standard potential. Note it down the points. It will be calculated under standard condition. Already we have discussed about it. Means the temperature should be 298 Kelvin, pressure should be 1 atmosphere and concentration of the electrolyte should be 1 mole per liter. Then it will be mentioned as, instead of ERP, it will be mentioned as ESRP, that is potential of standard reduction potential. So, definitely it is not possible to calculate absolute value or correct value of standard electrode potential. Once again, let me repeat, it is very difficult to calculate absolute value of standard electrode potential. So, only relative potential can be calculated. Please remember, only relative potential can be calculated. IUPAC have suggested SHE, Xi, which means standard hydrogen electrode. Now, the conclusion is, due to the charge separation, potential will be developed in both the half cell. Now, the second method, let me explain. It is non-standard condition. Means temperature must not be maintained 298 Kelvin. Same way, pressure no need to maintain as 1 atmosphere pressure. Concentration can vary. We will be, for this method, we will be using Nernst equation or Nernst equation. So, we will discuss the first method, standard hydrogen electrode. It is a gas electrode. It is a gas electrode. Note it down, children. It is a gas electrode. So, which gas will be filled? Hydrogen have to be filled. Hydrogen gas have to be filled. So, we have to use H plus solution. What is that? H plus solution, which means electrolytic solution should have H plus. Now, what is that? What for we have to use H plus solution? As I hope you remember, when we are using zinc as a electrode, we will be using zinc sulfate solution. Copper, if you use as a electrode, copper sulfate solution will be used. Same way, here we will be using the solution which is having H plus. So, it can be acidic solution and standard condition should be maintained. Now, let us discuss the apparatus part of it. So, okay, before we talk about the apparatus part of the gas, the representation of this standard hydrogen electrode will be platinum electrode / H2 in gaseous form and H plus in the aqueous solution. So, for this particular representation or particular cell, ERP of cathode will be equivalent to ERP of anode, always 0 volt. So, now the reference point is called the standard hydrogen electrode and consists of platinum electrode in contact with a hydrogen gas. As I have mentioned, it is contact with a hydrogen gas and aqueous solution, that is 1 molar solution. Quickly, now let us go through the apparatus construction part. It consists of platinum wire in an inverted glass tube. Hydrogen gas is passed through the tube at 1 atmosphere pressure, and in the diagram you could see on the top of the inverter tube there is an inlet. Through this hydrogen gas will be filled. A platinum foil is attached at the end of the wire. You could see the platinum foil, and the electrode is immersed in 1 molar HCl solution where H plus will be 1 molar at 25 degrees Celsius. The electrode potential of Xi is SHE is 0 at all temperature. Please, this is a most important point, note it down. The electrode potential of Xi is 0 at all temperature. And in the previous slide, you have learned how to mention the representation of this half cell. Using this value, we can consider or calculate all other potential because this value will be considered as a standard one. Standard hydrogen electrode, it is a primary reference electrode. Okay. Now, few difficulties. It is difficult to be used and to keep hydrogen gas at 1 atmosphere during all determination. It needs periodical replating of platinum sheet with the platinum black. Okay. Now, I think you are familiar with the diagram, whatever it is, like a galvanic cell diagram, you are familiar with this. So, here the reference electrode, that is hydrogen electrode, have to be cell have to be taken in the right hand side, and the potential to be calculated have to be taken on the left hand side. So, in the diagram, cathode hydrogen will be considered to be a cathode and zinc electrode will be considered to be anode. So, as we have studied, it will be connected, both the container will be connected with the U tube which will be having the electrolyte, inert electrolyte, we know about it, and the type of reaction carry over in this we are familiar with. On the oxidation half cell reaction will be zinc which will be donating that electron, so it will be converted into Zn2 plus, whereas on the right hand side hydrogen cell mein H plus will be absorbing those electron converted into hydrogen gas. So, now overall reaction will be zinc reacting with H plus to give Zn2 plus and H2. Now, we will talk about the important point. At 298 Kelvin, the EMF of the cell, that is standard hydrogen electrode, second half cell constructed by taking standard hydrogen electrode as anode and the other half cell as cathode. Okay. Now, which gives the reduction potential of the other half cell, which one we have to calculate for zinc, so that it will give the reduction potential of zinc electrode. If the concentration of the oxidized and the reduced form of the species in the right hand half cell are unity, then the cell potential is equal to what? Equal to standard electrode potential. Okay. So, now when you talk about this, these two containers connected with U tube and the second electrodes which will be connected along with the voltmeter or galvanometer to measure the voltage. The pointer can deflect in both the side in the galvanometer before the value can be either positive or negative. Please remember, the value can be positive or negative. Whatever the value of the voltmeter which gives a value for the complete cell, which is cell? Zinc cell, because for the other one we know that the unit the value will be 0. Okay. Now, once again let me repeat, whatever the value of the voltmeter which gives the value for the complete cell. Now substitute the value we get from the above experiment in the given formula. Okay. Now in this we know the value of hydrogen electrode will be 0. So standard electrode potential will be equivalent to standard reduction potential of zinc in cathode. Okay. So now what is the value? Minus 0.76 value. It is a experimental value. Similarly, we can calculate for copper electrode as well. So use the same formula. Instead of zinc, we will be replacing it with copper. Okay. Here for copper, we will be getting 0.34 volt. Here plus 0.34 volt. Okay. So no need to memorize these values because the value will be given. If we use zinc or copper electrode, it will be set up of Daniell cell. I think children you can remember about this. Now remember to write the cell notation. How to write cell notation? Anode have to be written first, then followed by salt bridge. The last one will be cathode. Okay. Now we will be combining zinc and copper electrode as a galvanic cell. Now when you are writing cell notation, Zn to gives Zn2 plus after donating electron, that is oxidation reaction will be written on the left hand side, whereas reduction reaction will be written on the right hand side. You could see zinc converted into Zn2 plus. Please mention which state it is. Zn2 plus will be in the aqueous form, whereas Cu2 plus will be converted into Cu. Cu2 plus will be in the aqueous form. So if you are writing cell notation for this particular reaction, practice this. And for this reaction, if you are talking about cell potential, it will be 1.1 volt. How it is? For copper already we have got plus 0.34, whereas for the zinc electrode we have got minus 0.67. So substitute the values in this formula. So we will be getting 1.1 volt. From this tabular column we can understand few important points. Electrodes with a positive E0 value for reduction half reaction do in fact act as cathode versus Xi, while those with negative E0 value of reduction half reaction behave instead as anode versus Xi. So to decide which one have to be taken as anode or cathode versus Xi will be based on the values whatever we are getting, whether it is a positive or negative. So the electrochemical series, all the elements whatever given may not be important. So let me tell you the list, please note it down. Lithium, potassium, calcium, magnesium, aluminium, zinc, chromium, iron, cadmium, nickel, tin, hydrogen, copper, iodine, silver, mercury, bromine, chlorine and fluorine. Okay. In this, the negative sign of standard reduction potential, for example lithium, which is having minus 3.05, indicates that an electrode when joined with Xi acts as anode, and here oxidation occurs on this electrode. Okay. For example, standard reduction potential of zinc is minus 0.76 volt. Just now we have discussed about it. When zinc electrode is joined with Xi, it acts as an anode. Oxidation occurs on this electrode. Similarly, the positive sign of standard reduction potential indicates that electrode when joined with Xi acts as a cathode. And which type of reaction will occur? When you say cathode, a reduction reaction will occur on this electrode. Okay. Now electrodes with positive value for reduction, while those with a negative value for the oxidation. Okay. Now cathode mein high SRP will be reduced. Okay. Now because metal can donate to attain stability, metal can donate electron to attain the stability. So, different to observe electron for this active metal. So, E naught value will be very less for which element? Lithium. Whereas, when you talk about hydrogen, water molecule, it can be included in both oxidation as well as reduction. Okay. When you are talking about a water molecule which donates hydrogen and 2 OH minus, which means it is undergoing for a reduction reaction. Whereas, when it is donating 4 electron, that means this reaction occurs in the oxidation process. Okay. Let me talk about few important characteristics of this electrochemical series. The first one is, all those substances which have positive values of reduction potential are placed below hydrogen in the series, and if it is placed below hydrogen series, it will be weaker reducing agent than hydrogen. Whereas, the substances which are stronger reducing agents than hydrogen are placed where above in the series and have negative values of standard electrode potential. Okay. Here you can remember lithium and fluorine. Okay. The substances which are stronger oxidizing agent than hydrogen ion are placed below hydrogen in the series. Do you understand this? The substance which are stronger oxidizing agent than hydrogen plus ion are placed below hydrogen in the series. Okay. The next one is, the activity of metal decreases from top to bottom. I am talking about the series. The activity of a metal decreases from top to bottom, whereas the non-metals on the bottom have high positive values of standard reduction potential. Example is fluorine. Okay. Have a tendency to accept electrons readily. These are active non-metals. Okay. The activity of non-metals increases from top to bottom. Okay. Now, using this, you can understand about the electrochemical series, how to use the EMF value. Okay. So, I want you children to revise this using the next tabular column, whatever I have mentioned. Children, practice this list mentioned in this slide and compare the value whatever I have explained along with this slide. Let me discuss about it in the next session.